Okay, today's lesson will still look at graphs and functions, and the specific objectives that you have to cover up by the end of the lesson is to find the y-intercept from the line graph. So in other words, you must be able to locate the y-intercept of the line graph on the Cartesian plane. And then the next basic specific objective is to find the gradient of a straight line. So the gradient of a straight line basically means you need to calculate the steepness or the slope of the straight line graph. But this one will have to perform calculations. So we need to do the calculations of the gradient of a straight line. And the last basic competency there, a specific objective there, is now find the equation of a straight line. Now in order for one to find the equation of a straight line graph, you must be able to find the y-intercept. You must be able to have the gradient of the straight line, and then you combine the two to find the equation of a straight line graph. Alright, now in the previous lesson I already indicated the general equation of a straight line graph being y equals mx plus c. So in other words, the y is our dependent variable, the m is our gradient, x is our independent variable, and c is our y-intercept. So looking at this equation and the three objectives, what we actually have to calculate here is the first bullet point objective, find the y-intercept from the line graph. It means that we need to find the value of c. And then to find the gradient of a straight line basically means that we need to find the value of m from the straight line graph. And then once we have the value of m, we have the value of c, then we substitute them into the general equation to formulate the equation of a straight line graph. Okay, so what I have here, I already have a line graph which is drawn for you. So in order for one to be able to answer these three specific objectives, the straight line graph must be provided to you. So the first objective here says that we need to find the y-intercept from the line graph. So when a line graph is already drawn for you, it's very easy for one to find the y-intercept, because all you have to do is just look at the line graph and check where the line graph meets the y-axis, where the intercept. So the vertical line is our y-axis, the horizontal line is our x-axis. It has positive numbers on the right, negative numbers on the left, and then our y-axis has negative numbers down and positive numbers up. Now, y-intercept, where does our line graph meet the y-axis? So this is my y-axis, the vertical one. So where does the line graph, which is now line AB, graph AB, where does graph AB meet? Where does it intersect with the y-axis? So looking at this graph, line AB intersect the y-axis at positive 2. So in other words, the y-intercept of our line graph AB is positive 2. So to answer the first specific objectives, to find the y-intercept from the line graph, you only look at the line graph which is presented to you and check where that line graph and the y-intercept meet. So that one is very easy to find, because all you have to do is just look at the graph and see where the line graph and the y-axis meet. So our value of c is positive 2, which is now our y-intercept. Getting back to the second part, find the gradient of a straight line, the steepness. Like I mentioned earlier, gradient of a straight line needs to be calculated. So there are two formulas that one can use. So to find the gradient, which is m, we can use the formula of change in y over change in x. So I will give you two formulas, and then you're going to see which one is easy for you to use when you are doing the calculations. Now using this formula, change in y over change in x, always find it easier if you have to draw a right angle triangle using the straight line graph here that is given to you. Try to form a right angle triangle meaning the hypotenuse with the longest side of your right angle triangle must be part of this line here, the line graph which is already drawn. So looking at this, I can form my right angle triangle by drawing it in this format. So I'll use my orange chalk for you to be able to see. So it's to the right and then up. You see that right angle triangle to the right and then up. The hypotenuse is part of a straight line graph which is drawn. Now, once you have drawn your right angle triangle, it's very important that you need to check the spaces, the length from this corner to that corner. So since this line is parallel to that, it means that the distance from this corner to that corner is 2 blocks. So we can say it's 2 centimeters. So the distance from here to there is 2 blocks. Now since I moved to the right, it's going to be a positive 2. Now from here to there, it's 2 blocks. Now you have to count the distance from here to there, to that corner there. So looking at this, I'll just have to use the scale on my Cartesian plane. So from here to there, it's 1, 2, 3, 4, 5, 6, meaning I moved up 6 places. So the distance from here to there is 2, that is to the right, and up it's also 6 places. Now we move to the right. This is now what we call my change in x, because this is parallel to my x-axis. Now going up, I have 6 places. I moved up 6 places. Now this line, when I moved up, this is my change in y. This is the side which is parallel to our y-axis. So now we use these 2 values to substitute them into the formula that is given. Alright, so what is my change in y? My change in y is 6. I moved up 6 places, so it's positive 6. My change in x, which is now the side which is parallel to the x-axis, from this corner to that corner, I moved 2 places. So it will be 6 divided by 2. Then you calculate 6 divided by 2, that will give us what? It will give us positive 3. So our y-intercept is positive 2. That's where the straight line meets the y-axis. And our gradient, which is now the steepness of this line, is positive 3. Using the equation that was given in the right angle triangle method. Now one can try to use another triangle. So one can form this triangle. You can draw a triangle this way. This is still another right angle triangle. So keep in mind the direction. So I moved to the left. So if it is the left, it's going to be a negative number. And then you moved down. It's also going to be a negative number. So when you take the left movement, you get a negative number. Left and down movement gives you a negative number. Right and up movement gives you a positive number. So I moved to the left. Now I have to check the distance from this corner to that corner. This is parallel to the x-axis. So meaning this will give me positive 1. I mean negative 1. So the distance from here to there to be negative 1. Now you have to count the distance from here to this side, to this corner here, because this is where my right angle triangle is. So from here to there, I'll have 1, 2, and 3. So since I moved down, that will be my negative 3. So movement is negative 3. Now this distance is parallel to the x-axis. So this is now my change in x. This distance from here to there is parallel to our y-axis. So this is my change in y. So substituting this information into that formula, we'll have the formula is change in y over change in x. So change in y is our negative 3. And our change in x is our negative 1. So negative 3 divided by negative 1, it will give us positive 3. So the gradient will remain the same, regardless of how small or big your triangle is. Now that is one method that one can use to calculate the gradient. Now let's look at another method that one can use. That is the first method. Another method that you can use, looking at the same line graph which is drawn, we can have the formula which is y2 minus y1 over x2 minus x1. So this method requires you to choose two coordinates on the straight line, two ordered pairs on your straight line graph. So for example, you can choose, if you decide to take this pair and that pair. So this pair here, the coordinates of that point is -1 on the x-axis and -1 on our y-axis. So we have -1 and -1. The coordinate of this point here is 0 on the x-axis and +2 on the y-axis. So this is my first pair and that is my second pair. So this being my first pair, the -1, the first coordinate is from the x-axis. So this will be my x1. And the second coordinate is from the y-axis. But this is my first pair. So the -1 is now will be now my y1. Now the second pair, the first digit here, which is the 0, is from the x-axis. So considering that this is my second pair, the 0 will be my x2 and the 2 will be my y2. Why? Because the 2 is from the y-axis, the 0 is from the x-axis. Now I have labeled my coordinates correctly. So -1 is x1, the other -1 is y1. The next pair, x2 is 0 and +2 is from the y2. Now you have these labeled coordinates which you have to use now to substitute into the given equation, which is y2 minus y1 over x2 minus x1. Alright, now getting back to that formula. So what is our y2? Looking at these coordinates here, the coordinate that we labeled y2 is +2. So y2, we replace that with +2 minus y1. What is our y1? Our y1 is -1. So it's a negative number, we need to put it in brackets. So it's 2 minus -1 over divided by x2. What is our x2? Our x2, the value of x2 is 0, minus the value of x1. x1 is -1. So we also have to put that in brackets. Okay? So we have now 2 minus -1, which will give us +3, and 0 minus -1 will give us +1. So at the end of the day, we have 3 divided by 1, which gives us what? Which gives us +1. So our gradient is +1. So regardless which method that you use, whether you use this method or you use this method, the gradient will remain the same. Now getting back to our specific objectives. The first objective, we have to find the y-intercept. So our y-intercept is +2 because this is where our straight line meets the y-axis. The second objective is now to find the gradient of a straight line. Even though it says find the gradient, basically gradient needs to be calculated. So we need to calculate it either using that method change in y over change in x, or using the method of y2 minus y1 over x2 minus x1. So this part we have now covered the first two objectives. Now getting back to the third objective, the finding the equation. Now the equation of a straight line graph is very easy once you have completed the first two. You have your y-intercept, you have your gradient. So now writing the equation. So the equation of the straight line, because the general equation is y equals mx plus c. So we now just have to substitute the values that we have already calculated into this general equation. So you rewrite the y, the value of m is now the gradient that you calculated, and we found that the value of m, this is a +3. So we found that the value of m is +3. So we replace the m with 3, and then you rewrite the x. The value of c is where the straight line meets the y-axis, and the value of c here, in our case, is positive 2. So we write positive 2. So the equation of our line graph is y equals 3x plus 2. Okay. Now here again, we have another graph. It's another straight line graph. So the three basic specific objectives there: find the y-intercept, calculate the gradient, and write down the equation of a straight line graph. Like I alluded earlier, finding the y-intercept is very easy because you just have to check where does your straight line meet the y-axis. Our straight line graph meets the y-axis at positive 1. So the value of c is positive 1. That one we just have to read from the graph. The first objective is done. The second objective is now to find the gradient of our straight line. So to find the gradient of the straight line, we need to calculate it. How steep is the straight line graph that is given to us? So we have two equations that I showed you. We'll just go over them again. So we'll use the first equation, which is now change in y over change in x. So here we draw our right angle triangle, keeping in mind that the straight line graphs forms part of the hypotenuse of our right angle triangle. Hypotenuse is now the longest side of your right angle triangle. Okay, now let me use this small triangle here, right angle triangle, if I form that. So look at how I drew my right angle triangle. I moved to the right and up. So to the right, this is now my change in x because this is parallel to our x-axis. And then I went up, that's my change in y. This line is parallel to our y-axis. Now I need to check the distance from here to there. This is 1 block. So meaning that would be our 1 centimeter is just 1 block. And then from here up there, the distance from here to there, it's 1, 2. So that's a positive 2. So it's 1 to the right and 2 up. 1 movement to the right and 2 movements up. So now we use these numbers to substitute it into the equation. So what is our change in y? Our change in y is now our up movement, which is positive 2. And our change in x is now our right movement, the horizontal movement, and we moved to the right, so that's a positive 1. So we have 2 divided by 1, which gives us what? Which gives us positive 2. That's now method 1. The method 2 is the one where you have to choose 2 points on your straight line, any 2 coordinates on your straight line. So if you are to choose this coordinate that pair, the other 2 pairs. So this is my first coordinate and these ones are my second coordinate, ordered pairs. Now what are the coordinates of this point? So at this point we have positive 1 on the x-axis and positive 3 on our y-axis. So it's positive 1 on the x-axis and positive 3 on our y-axis. So basically means that this will be our x1, that will be our y1. The second pair, ordered pair, we have positive 2 on the x-axis and positive 5 on our y-axis. So the pair here is positive 2, positive 5. Since it's my second ordered pair, the 2 from the x-axis will be my x2. The 5 from my y-axis will be my y2. Good. Now we move on to calculating the gradient. Now the gradient that we have decided to calculate, or the method to use, is now y2 minus y1 over x2 minus x1. Go back to the ordered pairs that you chose. Which one represents your y2? y2 is positive 5, so you write 5 minus y1. Our y1 is positive 3, so it's 5 minus 3 over x2. What is our x2? x2 is represented by positive 2 minus x1. So our x1 is positive 1. So here we have 5 minus 3 divided by 2 minus 1. Further on with our calculations, we now have to calculate what is 5 minus 3. 5 minus 3 will give us 2. And 2 minus 1 will give us positive 1. So at this step here, we have 2 divided by 1, which is positive 2. So the gradient that I have here is positive 2. The gradient that I got in the other formula is also positive 2. So regardless of which method that you use, the gradient remains the same. Our y-intercept is positive 1. Our gradient is positive 2. Now we have the gradient, we have the y-intercept. We move on to the third objective, which is now to find the equation of a straight line. So what is the equation of our straight line graph? The general equation is y equals mx plus c. So let's start with the substitution method.